Q is equal to N. What were the formulas that we went through in the last lecture? First, it was what? Wait. I said like good evening, ma'am. Good evening, ma'am. I said many times, ma'am hasn't even unmuted her mic. Still, you do your work. No, but she's showing what type B. I mean type A. You can send a message in the chat. Ma'am, your mic is on. Sabha, ma'am. Yeah. What were the formulas that we studied in the last lecture? Safia, can you recall all those formulas? Yes. What is the first formula? I is equal to Q by T. Was this the first formula? Start from the start. First, quantization of charge. The formula of quantization of charge was the first formula. That is Q is equal to IT, right? I'm sorry, Q is equal to NE. Okay. Yes. Also, can't you? Why aren't you saying charge on an electron? 1.6 into 10 power minus 19 coulomb. Okay, charge on an electron. And the third formula that we studied, this is not a formula, this is actually the magnitude of an electron. The third formula, that is of electric current. I is equal to Q by T. Okay, so these were the third formula that we went through in the first topic till yet. Q is equal to N. Why? N, what about N? Can N be any other value, like any type of values, or only the integers? N is only the integers. I'm saying that my voice is getting in 10th. Your voice is getting in 10th class. N is the integers. Okay, where it should be only positive integers. It should be only 1, 2, 1, 2, 3, 4 type of, not 1.5. Not like this. It should not be 1.5 or 0.5. Means it's just like a banana that you go to any shop and ask for banana, and you cannot ask for 1.5 banana, right? You cannot ask for 1.5 banana. What you can ask for? You can ask for either 1, 2, 3, or dozen of banana, any of the 100 bananas, whatever. But you cannot ask him to give you 2.5 banana or 100.4 banana. It cannot be given, right? It cannot be given. Okay, so what you can use here, 1 or 2, 3, only the integers value, right? Only the number that is 1, 2, 3, 4, only the whole numbers, or right, whole numbers, 1, 2, 3, 4, 5, 6, 100, 1000. That is why here it's written as Q is equal to Ne, number of electrons. This is actually quantization, means quantum is nothing but refers to packet. This means packet. In a packet, how many electrons are there? In a packet, how many electrons are there? Okay, so quantum refers to the word packet. Okay, got it? Got it now? Yes or no? And tell me, Safia, that day I did one of the question. That is, yes, Q is equal to N. Was this the question? How many electrons will be there? Can you, no, you have to solve this, that how many electrons will be there? How many electrons will be there? In one coulomb of charge. Just do it. Do it, Safia, and tell me. Means the whole calculation. You have to do the whole calculation. Okay. Which formula to use? What is given? What you are already knowing, and what to find? This you have to figure out and solve it for the number of electrons. We have to do 1 by 1 into 10 to the power minus 19. Yes. What you say? We have to do 1 divided by 1.6 into 10 to the power minus 9. Okay, which formula to use? First, tell me. First, you have to write. Q is equal to Ne. Okay, Q is equal to Ne. I asked you to solve this now. First, you have to write what is given. What is given? That Q is equal to 1 coulomb. You are given this. And charge on an electron, you are knowing that 1.6 into 10 power minus 19. And you have to solve for N. Okay, this will be your first step. Then second step, this, writing the form. And then you'll use, because you have to solve for n, so you have to leave it alone, q by e. Okay, now what answer you have got without using calculator? Without using calculator, don't use calculator. Solve it by yourself. Solve it by yourself. Solving now. What value of n you have got?
6.25 into 10 to the power minus 18.
Minus 18. Minus 18 or plus 18?
Yes, ma'am, 18. It's just 18.
Plus 18. It's a number of, because it will be having no, it will be having, just don't forget to write C here also, because it's a charge now. Okay, and there you'll use no unit for n, because c by c it will get cancelled, column by column it will get cancelled, because it's just a number. Okay, now we'll do question. Current of, because we already are knowing the what we call that, we already are knowing the formula, three formulas, q is equal to ne, no, mainly two formulas, q is equal to ne and q is equal to I. Okay, I is equal to q by t means q is equal to I. So these two formulas we are going to use in these questions. A current of 150 milliampere flows through a circuit for 2 minutes. Okay, for 2 minutes. So can you do this question by yourself? I will not show you the. I will not show you the. Okay, ABC. Can you do this question? Do this question. Write the given first, then write the formula which you will be going to use, and then solve for. Done, Sophia? So what you have got?
I'm doing.
What you have got? You're doing the question?
Yes.
Okay. Are you getting stuck anywhere? Are you getting stuck anywhere, Sophia? Fine. Do it and tell me. Complete and tell.
Charge will be 180.
Yes. Yes, Sophia. What you said? 180 column. Okay, let me see if your answer 180 column. No, it's 18 column. Find out where you have done the mistake. Should be 180. No, sorry, it should be 18.
Can you repeat?
18 column. So I've written here.
The answer will be 18 column. Yeah, okay.
Done, Sophia?
Yes, ma'am.
Have you done?
Yes, ma'am.
So tell me now, how answer you have got it or not? 18 column.
Yeah, I got 18 columns.
This is what I'm asking. Say. Okay, then you have got 18 column. Next question is try this. Total of 6 into 10 power 14 electrons flow through a current carrying conductor when connected to an external power supply for 20 seconds. तो just उन पे ध्यान दो जो दिया हुआ है. तो what is given? Total of this. So n you are given कि 10 to the 6 into 10 to the power 46 electrons. Okay, कितने electrons हैं? Time is given 20 seconds. Find the value of current in the circuit. Okay, electrons flow through a current carrying conductor when connected through an external power supply for 20 seconds. So you have to solve for what? I. You have to solve for I. That I, can you solve it? Can you try? Will you try, or should I give you the hint?
Okay, ma'am.
Okay, just you try. Otherwise, you have to use both of the formula. Yeah? Once you have derived the formula that will be used in this question, you'll solve. You're done. What happened? What is that formula that you're using here?
I was using Q is equal to NE and I is equal to Q by.
And what means combining both of them? What you got?
We get I is equal to NE by T.
Yes, this is the only formula that you'll use.
I got 1.6 into 10 to the power minus 19 into 6 into 10 to the power 46 divided by 20.
Is this the thing that you are getting? N, E, and T. What you said? What you are getting? What you said? I is equal to NA by T you will use here, right? So in place of N, what is the number of N?
It is 66 into 10 to the power 46.
And E 1.6 into 10 power minus 19. You have to do the calculation work also. You have to do that also. Okay. So cancel it out. First do this and this. 46 minus 19. How much it will be? 46 minus 19. How much it will be? 7, and then 3 minus 1 2 27. So you will be getting 6 into 10 power 27 into 27 to 1.6. Also you can write it, okay, cancelling it by 4, then you will get 5, and then cancelling it out by 4, so you'll get 0.4. Okay, and take out 110 from here. Take out 110. 6 into 10 into 10 power 26, right? 0.4. Okay, fine. Then what you can do? You can cancel out this 10 and 5. Can you do it or not? So 6 to the 12 and 12 into 0.4. How much
Okay,
it will
ma'am,
be?
I did it
0.8.
and I got 0.8 into 10 to the power 26
26. What?
amperes.
Amperes. Okay, because it's about I, so we'll use amp. So it will be okay. 4.8 into 10 power 26. Okay, we have done this question, and also we will do which question? This question. First, we'll do this question. This is the easy one. So we'll do first the easy one, and then we'll. This is the same question as that of the before that we have done here. I think this question. Okay, this is the same question. You can try this question at your home also. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Time is given. I is given. Okay, I is given. Time is given. Find the current or find the amount of electric charge. So you have to figure out for Q. So Q is equal to IT. Just you have to multiply these two numbers. But remember, 10 into 60 you have to do. Okay, because you have to take the standard units, seconds. Okay, now this question. Try this question. This question and this question. This is also the easy one. Yes, you can do the first part easily and also the second. Try these questions. First try this and then try or whatever you say. I is the current through a wire. Just do it by yourself. Totally by yourself. What happens up here? Hello. Okay, option D is correct. You can do all of the questions. Great. Now this. Do these questions. The more question you will do in this chapter, the more you get mastered. And also you try with the other books also. I already have told you this thing that in any of the question in any of the book, if you are trying the questions from, then you are free to ask me the question even from HC Verma or whatever. You just send me the question and then I'll tell you how to solve that question. Okay, and since you are a brilliant girl, so you must try the other books also. Okay, Safia, you getting now what I'm saying?
Yes, ma'am.
Yes, tell me, Safia. 48 column. Don't have answer of these questions. So I have to do this question by myself also so that I can got to know if you have done it correctly or not. So I is given 0.4 ampere and time is given as 2 minutes 120 seconds and it has asked for I. So it Q. So it will be IT will be 0.4 into 120. Okay, it will be how much? 4 into 12, that is 48 coulomb. Yes, correct. 48 coulomb. Now the second amount of electron passed through the wire. Amount of electron. What?
Ma'am, I've sent the answer. So,
Send the answer. 3 into 10 power 20. Have you done this thing?
yes, ma'am. Ma'am, I just multiplied 48 by 6.25 into 10 to the power 18 because that is the value of 1.6 into 10 to the power minus 19.
0.1. So it will be 30. 3 into 10 power 20. This is what you have got, no?
Yes, ma'am, but I just did it by using the value of 1 by 1.6 into 10 to the power minus 19.
So this is what I have done.
Yeah.
This is what I have done. I haven't written here. I just have written directly. I just took this 10 power minus 19 to the numerator in the first step itself. Okay. Done all these questions. Now you see electric potential and potential difference. What is electric potential and what is potential difference? Potential means कितना potential है कि हम कितना work कर सकते हैं, right? That how much work you can do, we can consider it as how much potential you have, right? How much work you can do in a given time limit, that we define it as potential. Your potential. How much is your potential? Means how much work you can do in what in a given time, right? That will be considered as your potential, right? If you can do large work in less time, then it will become then I'll say that yes, you have a great potential, right? If you can do if you can do 20 questions in 10 minutes, then I'll say yes, you have a great potential, right? And if you can do 10 questions in 20 minutes, then I'll say that you have an average potential, right? So in this way इलेक्ट्रिक पोटेंशियल की भी बात होती है, ठीक है? इलेक्ट्रिक पोटेंशियल की भी बात होती है, तो इलेक्ट्रिक पोटेंशियल पोटेंशियल डिफरेंस क्या है then we'll see कि इलेक्ट्रिक पोटेंशियल पोटेंशियल डिफरेंस क्या है। तो इलेक्ट्रिक पोटेंशियल ये है कि कि कितना काम किया जा रहा है एक यूनिट पॉजिटिव चार्ज को, एक यूनिट पॉजिटिव चार्ज को, हाउ मच, सपोज दिस इज अ पिंक पेन, हाँ, suppose this is a region where my electric charges are there, electric field is there, okay, where my electric field is there. Here are many of the electric charges, okay, there are many of the electric charges, and here the electric field is there, okay, due to the electric charges the electric field comes, okay. So now we'll say key in how sorry, yeah, in moving a unit positive charge, in moving a unit positive charge from infinity to that point means to the point inside the electric field, okay, to the point inside the electric field. In the work that is done in moving a unit positive charge in bringing from infinity to that point means in the electric field. This is called electric potential. This is called what? Electric potential. This is called electric potential. Now, what about potential difference? What about potential difference? Yeah, this we can consider it as electric potential. We take it as V. Okay, electric potential we take it as V. How much work is done in moving a unit positive charge from infinity to the point of electric field, that is called in unit time, that is called what? Electric potential. Okay, yes, see, amount of work done when a unit positive charge is moved from infinity to that point, okay. Sorry, W by T. Why I have written here T? It will be Q, unit positive charge. This will be charge, okay. Okay, I was talking about T for you, so I wrote T. Q, W by Q, okay. So, see, if work done in moving a unit positive charge Q from infinity to the point to the point is W. अगर चार्ज क्या है? पॉजिटिव चार्ज Q को हम कितना इंफिनिटी से पॉइंट मिलाने के लिए work done is W, then how will we denote electric potential? We'll denote it by W by Q. Okay, W by Q. And what will be its SI unit? Its SI unit is V, but also it's deriving it from this formula. So what it will be? Joule per coulomb. Joule per coulomb. Or you can write it like joule per coulomb. And to this we write it as volt. Okay, joule per coulomb we write it as volt. So समझी कि what is this electric potential? The amount of work, that is the amount of work done when a unit positive charge is moved from infinity to the point, that is called what? That is defined as, this is defined as electric potential. Okay, electric potential difference. Now electric potential, and it is a scalar, it does not have any direction. Electric potential is, it is defined as the work done inside the, ये किसकी बात हो रही है? रीजन ऑफ चार्जेस की बात हो रही है, जहां पर चार्जेस ऑलरेडी हैं, यहाँ पर इसकी बात, इस यही की बात हो रही है, यहीं पे चार्जेस हैं, ठीक है, यहीं पे जो है चार्जेस हैं बहुत सारे, ओके, यहीं पे बहुत सारे चार्जेस हैं, ओके, यहाँ बहुत सारे चार्जेस है, ये इलेक्ट्रिक फील्ड है, यहाँ पर इलेक्ट्रिक फील्ड वी डिनोट इट लाइक दिस इलेक्ट्रिक। अब यही इसी रीजन में from this point in moving a unit positive charge from this point to this point, from this point to this point, how much work is done, in moving a charge from one point to another point in an electric region, in an electric field, तो उसे कहते हैं क्या? उसे क्या कहते हैं? पोटेंशियल डिफरेंस, दैट इज कंसिडर्ड एज V2 minus V1 is equal to W by Q. Q you can denote it by smaller q or capital V2 minus V1, that is equal to W by Q. Okay, or you say VB minus VA, okay, from B point to A point, from A point to B, or you say V2 minus V1. So it is defined as work done in moving a unit positive charge from one point to another in region of charges, that is the region of charges where the electric field is there. So let W be the work done in moving charge Q from point B to point A, then potential difference VB minus VA between these 2 points will be given by this. VB minus VA is equal to W by Q. Okay. The electric potential difference between 1 volt कब होगा? जब 1 जूल वर्क होगा और 1 कूलम ऑफ चार्जेस को हम इधर से उधर मूव करेंगे. ठीक है. तो VB minus VA when it will be voltage V when it will be 1 volt when we will be having 1 joule of work in moving 1 joule of work in moving 1 coulomb of charge. Okay. तो वो हो जाएगा 1 volt is equal to 1 joule by 1 coulomb. That will be 1 joule per coulomb. That will be 1 volt. Okay, got it? तो ये हमारी बात हुई इलेक्ट्रिक पोटेंशियल एंड पोटेंशियल डिफरेंस. ठीक है. तो रेस्ट वी विल बी सॉल्विंग इन द नेक्स्ट क्लास. ओके, फाइन फाइन. तो I will also share this page so that you can try these questions. Example 3 and example 4 also. Okay, try these questions. So bye for today.